Welcome to Design Technology in Key Stage 1. This is a dedicated presentation for the Flying High Trust and is delivered by Lawrence Keel. This presentation is designed for school leaders, design technology subject leads and teaching and learning staff in Key Stage 1. In this presentation we are going to cover the following: a brief overview of the design technology curriculum in primary schools and some of the underlying principles that can be applied when designing a scheme of work for the subject to ensure effective teaching and learning in the subject and to secure the best outcomes for children in design technology. We shall touch briefly on the pedagogy of teaching design technology using 4 different types of lessons, but the main focus of this presentation is looking at detail at the curriculum content for the subject. First, we will look at the disciplinary process and how the subject works in terms of developing knowledge of designing, making and evaluating in Key Stage 1. This will be followed by an in-depth look at the curriculum content in the strands of learning relevant to Key Stage 1. Having considered the curriculum content, we complete this presentation with how to support children who may struggle or excel in the subject and how to construct a curriculum that ensures that children progress to the curriculum endpoints and how an effective progression map can be used to drive forward assessment in the subject. Design technology at Key Stage 1 should build upon children's learning from their experiences in the early years. An effective early years unit will lay the foundations for children's future learning in design technology. In the early years, children should have the opportunity to explore and investigate a range of products, materials and tools, finding out how they work and how they can be used. They should experience making and constructing things using a variety of materials and tools. Children should experience exploring food and making simple food products, and through this will begin to learn some simple cooking and food preparation skills. In all these learning activities, children will be talking about their experiences, asking and answering questions, learning new words and giving their views and listening to the views of others. Effective provision for design technology based activities is covered in more detail in the separate presentation for the Flying High Partnership. The aims of the National Curriculum for Design Technology is to provide children with the knowledge, skills and expertise to participate successfully in a world where technology is advancing rapidly. It encourages creativity in children by challenging them to design and make a range of products that could be used by a wide range of users. As part of this creative process, it encourages children to evaluate, reflect upon and test out their ideas. To support them in this process, children should learn about people who are successful in the world of designing and making and have made a significant contribution to advancing technologies. A significant part of the design technology curriculum in primary schools is devoted to children knowing, understanding and applying the principles of healthy eating and nutrition when learning how to cook. These are a summary of the aims of the national curriculum. It also provides guidance on teaching children the knowledge, understanding and skills that they need to design and make products, as well as a brief overview of the technical knowledge that children need in order to design and make their products. When designing and making their products, children should work in a range of relevant contexts, meaning that the products that they are creating should be relatable to the real world and relevant to the children's lives. Whilst design technology can be considered a practical and creative subject where children apply a range of skills and techniques, at the heart of the curriculum must be the knowledge that the children need to learn to be creative and successfully carry out those practical skills and techniques. Using the content from the national curriculum, all the knowledge that the children need can be split into 2 distinct areas of knowledge. First, there is the disciplinary knowledge that focuses on how the subject works and the creative and iterative processes of designing, making and evaluating. And as part of that process is the importance of children developing a technical vocabulary and also knowing about successful designers and inventors who do the subject well. Because if you want to know how a subject works or to get better at the subject, then study the people who do the subject well. Second is the technical knowledge, and this includes developing knowledge about products, knowing how they work and how they are made. Using guidance from the national curriculum, this learning can be divided into 6 strands of learning: cooking and nutrition, materials including textiles, structures, mechanical systems, electrical systems and program systems. At Key Stage 1, children are focused on cooking and nutrition, textiles, structures and mechanical systems. And when they transition into Key Stage 2, they widen this focus to include electrical and program systems. This diagram shows how the curriculum can be implemented as a progressive scheme of work that delivers the curriculum endpoints at the end of Key Stages 1 and 2. Through studying content in the 6 strands of learning from Year 1 to Year 6, children acquire the knowledge and experiences of designing and making and evaluating products, whilst also gaining the technical knowledge, practical skills, vocabulary and the knowledge about designs and designers associated with each strand of learning. And this diagram shows one way of delivering the strands of learning in a curriculum long-term plan for design technology, where design technology is taught once each term. Such is the importance placed on cooking and nutrition within the national curriculum that a unit of work is taught each year that focuses on cooking and nutrition. Materials, and this is often a textile-based project, is taught every other year, as our projects focus on building structures. The final strand has the common thread of systems, in which children include either a mechanical, electrical or program system as part of their product. It would be expected that these products would be more complex as the children get older, and it is likely that products developed as part of the electrical and program system projects would also include elements of children's learning about materials and structures. As well as ensuring that your school curriculum meets the requirements of the national curriculum, here are some other areas of curriculum provision that you might want to think about. Time allocation. There is no specific guidance about the amount of curriculum time that should be devoted to teaching design technology. Most schools have opted to teach the subject over 3 half terms during the academic year, and this is the approach that we have taken in our scheme of work. The key question to ask yourself is whether children are reaching the expected standard at the end of each key stage, and as part of this, whether the curriculum is covering all areas of the design technology national curriculum. If the answer to either of these questions is no, then a key line of inquiry should be whether enough curriculum time is being allocated to allow the children to have the breadth and depth of learning in the subject. Linked to the amount of time allocated to the subject is the method of delivery in terms of how many topics are covered in each year group and how many lessons are used to deliver each topic to ensure curriculum coverage. Also worth thinking about is how the lessons are delivered over a unit of work. Are they delivered weekly with an opportunity for children to revisit, recall and consolidate previous learning? Are they delivered over a series of lessons during 1 week? Some schools have a design technology week each half term, with every afternoon devoted to the subject, or are they delivered as a design technology day with all the learning compressed into 1 day? Each of these approaches have their merits and their pitfalls, and different approaches work for different topics. What needs to be decided is what method of delivery for each unit of work produces the best outcomes for the children. Referencing how the subject is delivered should form part of any curriculum statement for design technology. In thinking about the curriculum content, breadth is important to ensure that the national curriculum is covered so that children receive their statutory curriculum entitlement. But the design technology curriculum is potentially vast and you cannot cover everything in depth, and so choose certain areas where the children will have opportunity to go deeper into the subject. So for example, if you are lucky enough to have a school garden or allotment, you could shape your cooking and nutrition units so that the children include ingredients that they have grown themselves. Or if you have woodworking equipment as part of your resources, you can include 4 or 5 units where the children create wooden frameworks as part of their learning across key stages 1 and 2. Or you could include elements of enterprise and entrepreneurship in your design technology units, with children creating products to sell to parents or at a school event, and make this a theme of design technology, particularly in key stage 2. Whatever topics you choose to include in your curriculum, have a clear rationale for the choices and make sure that this is articulated through your curriculum documentation. Resources. Design technology as a subject has the potential to be resource heavy, both through specialist equipment and also through consumable materials. In developing a curriculum, first undertake an audit of your current resources and see whether you are able to deliver the curriculum using these existing resources and working with what you have. Also, a tight scheme of work that clearly identifies the products that the children will be creating, along with the materials, tools and techniques needed, will allow the school to resource the subject more efficiently and buy only what you need. Also consider how the subject will be taught. For example, if the school does decide to include several projects that involve woodworking, then it is likely that practical sessions would be done in small groups, because you're unlikely to want to have 30 children all sawing wood at the same time. So you would only need to resource for maybe 6 saws and bench hooks. The same kind of approach applies to cooking and nutrition lessons, and whether the practical elements will be taught in small groups, half class sizes, or the full class. Resources for program systems and some elements of mechanical systems can be very expensive, and schools may wish to consider partnering together to share resources. However, this may mean aligning certain parts of your scheme of work. Cross-curricular links. Many primary schools follow a topic approach to teaching the foundation subjects, and often the driver for these topics are either history or geography related. This leads to teachers trying to link design technology learning to the ancient Greeks or to the Brazilian rainforests. As will be discussed later, one of the principles of effective design technology is that children design and make products that are real life and relevant. So designing and making a Tudor house or a Mayan headdress is not particularly real life and relevant to the children's experiences of Britain in the 21st century. Also, in using a cross-curricular topic approach, weaker subjects tend to be forgotten or badly taught, and so teachers who are not confident or lack subject knowledge tend not to teach the design technology content properly as part of cross-curricular work. If you do go down the route of cross-curricular topics, ensure that the DT content within the topic is clearly identifiable and matches the scope and ambition of the national curriculum. Within the DT curriculum, there are opportunities for children to apply their knowledge from other subjects, particularly subjects like maths, science and computing. And here we are looking at key skills such as measuring from maths lessons, applying the knowledge of properties of materials and simple circuits from science lessons, and using block coding to control products and computer software to design products from the computing curriculum. Considering this transference of skills and knowledge from one curriculum area to another highlights the need for curriculum coherence. And this is about ensuring that if we are asking the children to transfer these skills and knowledge, that they have already been taught them in these subjects. What we want to avoid is using valuable DT time to teach or reteach learning from elsewhere in the curriculum. Health and safety. Teaching design technology, due to its practical nature, can introduce an element of jeopardy into lessons. Part of successful and effective planning for each practical lesson is about reducing the risk. Risk assessments are not worth the paper they are written upon if they are written and reviewed every 3 years and then put away in some dusty cupboard and then signed by the teachers every September so that the school shows some degree of compliance. Risk assessments need to be a live document that reflects the current situation, the activities that are to be undertaken, and the nature of the children taking part and the risks involved in that particular lesson. As part of reducing this jeopardy, schools should have clear guidelines for the practical elements of design technology in terms of group sizes, techniques that are taught, and where additional adult support is needed. Make sure that staff receive appropriate training in teaching the techniques correctly and that all staff adhere to these routines and receive regular refresher training. Also, choosing appropriate resources can help to reduce the jeopardy. For example, when teaching children to grate carrots, make sure that all the graters are of the same design and size so that the children only need to know one technique. Staff need to be able to demonstrate due diligence when teaching practical activities and demonstrate that they have actively sought to reduce the risk. Finally, when considering the curriculum in DT, it is worth noting the soft skills that are often developed in the subject, such as getting organised, working as a team, discussions and decision making, cooperation and resilience. These will not happen by accident, and there may be times within lessons where these soft skills may need to be taught, or certainly children will need support in order to develop them. This may be another area that you want to include in any curriculum documentation in design technology. In our scheme of work, we include teaching slides and opportunities to help teach and support these vital soft skills. As part of the support package for schools in the Flying High Partnership, 2 audit documents are available for download from the Primary DT website. The Audit of Provision is a self-evaluation tool that focuses on curriculum provision. It is divided into several sections that address national curriculum coverage, design technology in the early years, the principles of design technology and how they are applied to the curriculum, how disciplinary knowledge and understanding is developed through the curriculum, the technical knowledge of design technology, and progression and assessment in design technology. Many of these areas are covered in this presentation. The second audit focuses on staff confidence and capability in the subject. This is a questionnaire for teaching and learning staff to complete that focuses on their confidence, knowledge and skills in teaching key areas of the subject, their understanding about key themes linked to disciplinary knowledge of designing, making and evaluating, their subject knowledge of techniques linked to the 6 strands of learning in the design technology curriculum and other areas such as health and safety and drawing techniques. The outcome from compiling the results from this survey may highlight the strengths and weaknesses in staff subject knowledge and point the way for further staff training and development. Research has shown that staff subject knowledge and the confidence to teach the curriculum content is the biggest barrier to effective teaching and learning in design technology. For those of you choosing to use the curriculum audit, Section 1 covers the content from this first section of the presentation, including curriculum provision linked to the 6 strands of learning in design technology. In this section, we are going to summarise the 5 principles of design technology that act as a driving force behind the development and implementation of a quality curriculum in the subject. These are the 5 principles that guided the development of our scheme of work. A more extensive overview of the principles are provided by a separate webcast available through the website. The 5 principles are listed on the screen now. They are: when working on a design technology project, children should create a product by both designing it and making it. For teachers, when developing a project or a unit of work, they first need to decide on the product that the children will create and then work backwards by identifying all the knowledge that the children will need to successfully create the product and finish the project. Perhaps the most important part of implementing a quality DT curriculum is the concept that children will be building their knowledge as they progress through the curriculum. So in each unit of work, children are revisiting prior knowledge, learning new knowledge, and connecting all this knowledge together to create a better understanding of the subject. For each product that they are creating, children should be making decisions about the design that makes their product innovative and authentic to them. It is highly unlikely that children will design something truly unique or innovative, but instead their designs are likely to be based on a similar product to which they adapt with their own unique ideas and creativity. In making these design decisions, children need to consider who they are making the product for and what is the purpose or function of the product. Technology is everything created by humankind. Understanding technology and how it is made and used helps children to understand the world around them. So, when working on DT projects, it is important that children are creating products that are real life and relevant to them. The final principle is that when children are creating a product, they should understand and apply the iterative process of designing and making. The iterative process in design technology is about the cycle of continuous improvement. It is about repeating the series of steps that are needed to create a product, with each repetition refining the previous version based on evaluation, feedback and testing of the product. This ultimately leads to continuous improvement and a final better product. Hopefully, most people understand the simple disciplinary processes of designing and making and evaluating that are needed to create a product. But if we include the iterative nature of the subject, the process should not be viewed as linear, but more of a cyclical nature, where, for example, we might evaluate designs and improve them before proceeding to make the product, the proverbial back to the drawing board. Or, as part of the creative process, we might make a model of a product, evaluate what we like about the product model, and then use this evaluation to inform the designs we create. In practice, with limited curriculum time for the subject, what we need to install in the children is the mindset of thinking about how can I improve my product as an ongoing process, and not leave evaluation activities to the final lesson at the end of the unit of work. For those of you using the curriculum audit, Section 3 is dedicated to ensuring that your curriculum delivers these 5 principles. It is recommended that you watch the separate webcast on these 5 principles before completing Section 3 of the audit. In this section, we are going to cover some pedagogical approaches to teaching design technology. Knowledge lies at the heart of the curriculum in design technology. This knowledge can be divided into 4 main knowledge domains: subject knowledge, technical knowledge, disciplinary knowledge, and practical knowledge. Essentially, teaching design technology is about providing children with that knowledge and then providing opportunities for children to apply this knowledge when creating a product. As children progress through the curriculum, they will know about products that they are designing and making and how these products work. They will know about techniques and processes needed to design these products. They will know about the skills, techniques, tools and materials needed to make these products. And they will know how to evaluate the products they have made and know how to identify ways to improve them. And through this knowledge acquisition and building, they will know more about the subject and how it works and the iterative nature of design technology. So, when planning a sequence of lessons or learning activities, teachers need to identify and understand the knowledge that the children need in order to achieve the learning outcomes for the activity, for the lesson and for the unit of work. This can be helped by having knowledge-based learning outcomes, which state what the children will know at the end of the lesson, or a skill or technique that they will know how to do at the end of the lesson. Research has shown that teachers' lack of subject knowledge in design technology is the biggest barrier to effective teaching and learning in the subject. Therefore, if there are any concerns about the quality of provision in the subject, perhaps the best place to start would be to focus on professional development to improve subject knowledge. Effective teaching and learning can also be supported by providing detailed planning or a scheme of work that clearly identifies the knowledge content for each lesson and each unit of work. Another highly effective strategy for improving subject knowledge is for staff to make the product that the children are going to create. Doing this before the project begins allows staff to identify all the knowledge, skills and techniques that are needed to make the product, and also to begin the process of sequencing this knowledge acquisition into a series of learning activities and opportunities. As children progress through the curriculum, they should be building and linking their knowledge and getting better at a range of skills and techniques. Therefore, as well as identifying the knowledge that children will know within a lesson or unit of work, teachers need to know what children know already, how much they have remembered, how secure this knowledge is, and whether further learning activities are needed to consolidate this existing knowledge. And when delivering new knowledge, how can it be linked to existing knowledge to create a better understanding? This highlights the importance of effective assessment for learning strategies in the subject. In a sequence of learning across a unit of work, there should be opportunities for children to consolidate existing knowledge, acquire new knowledge, and then apply this knowledge. This learning sequence can be delivered through 4 types of lessons. Units of work normally begin with a series of investigative and focused tasks. These are followed by the design and make task, where children have the opportunity to apply the knowledge, skills and techniques they have learnt in order to create a product. Through the investigative tasks and the focus tasks, children are provided with all the necessary learning and prerequisite knowledge that will allow them to successfully complete the design and make task. In investigative tasks, the teacher guides the children through investigations that allow them to find out and gain more knowledge about a product. Investigative tasks are about finding out about existing products that are similar and linked to the product that the children will be creating in the design and make activity. In the evaluate lesson at the end of the project, children have the opportunity to evaluate the product that they have created, but also to reflect on the processes that they have used and also on the project as a whole. Through participating in the design and make activity and the evaluation tasks, children will be consolidating and developing their understanding of the disciplinary knowledge of design technology and how the subject works. Having lessons that are knowledge-based will affect how the lessons are delivered and the role of the teacher within the lesson. For investigative tasks, the teacher guides the children through the investigations to ensure that from these tasks, children acquire the knowledge that they need. Investigative tasks are about finding out about existing products that are similar and linked to the product that the children will be creating in the design and make activity. Focus tasks are instructional activities that focus upon improving pupils' knowledge, gaining new skills, and improving and consolidating existing skills and techniques. Tasks can be designed to provide children with the knowledge of how a product is made or to practice key skills that are needed to make a product. Through focus tasks, children can learn about how to use tools properly and can develop a deeper understanding of the properties of materials and or the ingredients that they are working with. Focus tasks are an opportunity to provide specific technical knowledge of how a product works or how a system to be used in a product functions. Focus tasks are also an opportunity to teach children the specific skills and techniques associated with the disciplinary processes of designing, making and evaluating, such as developing their designing skills using mood boards, brainstorming, different drawing techniques and computer-aided design. They can be used to teach children how to conduct research through questionnaires, surveys, desktop searches and taste testing. They can be used to make a system to understand how it works and how it can be used in the final product. Focus tasks can also be about learning how to make a generic food product by following a recipe, which then children will adapt as part of the design and make activity. Focus tasks can also be used to teach children specific evaluation techniques. For these focus tasks, teaching is likely to be quite didactic, with all the children creating the same product or having the same learning outcome. The design and make tasks provide the opportunity for children to apply their learnt knowledge and understanding. There should be no new teaching of knowledge. Children should have all the necessary prerequisite knowledge to design and make their product. The teacher can support children in these sessions whose knowledge or application of this knowledge is not secure. In design and make sessions, the teacher acts as a coach or critical friend, stepping in when necessary to keep the creative process moving along and ensuring that children create their product. In the evaluation sessions, the teacher can lead and support the process of evaluating the product, providing prompts and ideas. But, like the design and make sessions, these should be very much led by the children. Design technology is a disciplinary subject, and to be successful in this subject, children need to be able to understand and apply the creative processes of designing, making and evaluation, and how they interact with each other as part of the iterative process and nature of the subject. As children progress through the curriculum, it is expected that they will understand more about the disciplinary knowledge and the creative processes of design technology, and be able to apply them to projects they are undertaking and products that they are creating. And we will begin by looking at designing. The national curriculum at Key Stage 1 states that children should be taught to design purposeful, functional, appealing products for themselves and other users based on design criteria, and to generate, develop, model and communicate their ideas through talking, drawing, templates, mock-ups and, where appropriate, information and communication technology. Throughout our scheme of work, we refer to design specifications instead of design criteria, but they are essentially the same thing. Looking at the creative process of designing, in order to be effective designers, children need to have knowledge to be able to design their products. They need to know about the products that they are designing, what they are used for, their purpose, how they might be made, and this includes knowledge of the materials and their properties that might be used to make the product and how it might be made. Having acquired this knowledge, they will use it to begin to generate design ideas. These ideas can then be looked at, improved, discarded, or developed into a final idea or solution to the problem that they are solving. From this process comes the final design, which needs to be communicated to the client or used when making the product. There are many different techniques that designers use to develop their ideas and designs and use to communicate these designs. We have identified 6 of these techniques which children can use in primary schools. These are introduced in Key Stage 1 and consolidated and developed as children progress through Key Stage 2. These 6 techniques are using design briefs and design specifications when designing a product, drawing to communicate design ideas, using mood boards to develop ideas and designs for a product, making models, mock-ups and prototypes as part of the design process, using computer software when designing, and brainstorming as a technique to develop and share ideas when designing. When designing products, children do so from a position of knowledge to help them develop their ideas and their designs. This knowledge can come from a variety of sources and includes investigating existing products. This is about children handling, exploring and playing with existing products, finding out what they do, how they are made, what materials we use to make them and how they work. Children can also undertake market research and desktop research to find out about products. This can be as simple as discussing a product with their friends, reading a book about a product, or online research finding out about existing products. Visits allow children to gain more knowledge about a product, how it is used in the real world, who uses the product, and knowledge about how they use this product. Sometimes there can be explicit teaching about products that provides knowledge about what they are, how they work, and how they are made. When working with food, it is all about creating a food product that tastes nice and that people will want to eat. So an important part of cooking and nutrition is to provide children with opportunities to taste test food and to develop a taste vocabulary to describe the taste, texture and appearance of food. Many of these types of activities are usually carried out towards the beginning of a project and are an opportunity to introduce the project, find out what children know already about a product that they may be designing, how much knowledge they are able to recall from previous units of work, and are an opportunity to add to the children's subject knowledge. So for example, in Key Stage 1, as part of a project where children design and make a teddy buggy, we might begin by investigating and playing with toy cars and seeing how they work. This provides an opportunity to teach children about the different parts of a vehicle, learn some new vocabulary, and also how the wheel and axle is a mechanical system that allows the toy car to move. We can also introduce children to the idea of rotational and linear movement. In this unit of work in cooking and nutrition, children are challenged to design and make a fruit salad. They might begin by discussing where to buy fruit and vegetables by applying their knowledge of the local area. This could lead to a visit to the local market, supermarket or convenience store to buy some fruit. This is also an opportunity to develop children's knowledge of names of a range of fruit and vegetables. These discussions, visits, knowledge acquisition activities and a simple survey of the class's favourite fruits provide an introduction to the children of the ideas of research and market research in design technology as a way of finding out more knowledge about the product they are going to design and make. These are further developed and built upon as children move into Key Stage 2. When working with food and designing a food product, a key element of the learning is taste testing food. In this project, children design and make a rainbow salad. Towards the beginning of the project, children have the opportunity to taste several different salads that have been bought from a local supermarket, such as coleslaw, beetroot salad and a crunchy bean salad. This activity provides them with the knowledge about what a taste test is and how to carry it out. It can also be used to develop children's taste vocabulary, which they use to evaluate these salads. At the end of the project, having designed and made their own rainbow salad, they then use the same taste test methods to evaluate their own salad and the salads designed and made by other children in the class. Once the children have knowledge of the product, they can begin the process of design using a range of design skills and techniques. The first one we are going to look at is using the design brief and design specifications for the product. Each project that the children undertake should include a design brief that tells them about the product that they are going to create or the problem that they are going to solve. Linked to this design brief are a list of design specifications that can include what should be in the product, how it should be made, or how it should work. For the project on screen, children are being challenged to design and make a dip and dipper snack to eat between meals. The design brief can be used as a guide for some of the knowledge that the children will need to successfully complete the project. They will need to know what is meant by a dip and a dipper, with the opportunity to try some of these out using a taste test. They will also need to know what is meant by a healthy snack. This is developed further through the design specifications in terms of children knowing what are the healthy eating messages in Key Stage 1, what is meant by prepared fruit or vegetables and which fruit and vegetables are suitable to make into a dipper, what information is contained on food labelling and why food is packaged. Once children have this knowledge from the design brief and design specifications, they can then apply it to design and make their food product. Drawing is an essential tool of the designer. As children progress through the curriculum, they should learn about the different types of drawing and how they are used in the design process. In Key Stage 1, children should learn about how designers use sketching to quickly get down their ideas and how sketching is used to develop and refine these ideas. They can also learn about how designers use drawings to finalise and communicate their design ideas and how labels and simple annotations are used to add more information and help to explain their design ideas. Like all the design techniques, drawing needs to be taught and practiced through guided activities and focused learning. For the project on screen, children design and make a celebration card for a special occasion. This celebration card must have a movable element as part of the design specification. Taking into account the nature of the celebration and the person they are making the card for, children create some quick sketches of their ideas and share these with a group of friends who provide them with feedback. Acting on this feedback, children create a final design idea for their celebration card and communicate their design through a labelled drawing which shows part of the card that will move and the direction that it will move in. In Key Stage 1, children can use models to help them understand how products work, how they are made, and also how models can be used to communicate their design ideas. In this project, children design a monkey enclosure for the local zoo. When they are happy with their design, they create a model of their design to communicate their ideas for the new enclosure. This project can easily be adapted to allow children to design and make a model playground or to design and make a tree house for the garden. Mood boards are very much a technique used in Key Stage 2, but some of the foundations of using a mood board can be laid down and developed in Key Stage 1. A mood board is a technique used by designers and is a visual way of developing, sharing and presenting their ideas. Mood boards can be particularly useful if children are working as a group, as a stimulus for group discussion about their ideas, or as a way of recording their ideas following these discussions. Mood boards can be introduced in Key Stage 1 by creating a whole class mood board display of their ideas and designs for a particular product they are designing. For example, in this treehouse project, to help them develop their ideas for a new treehouse in the local park, children might visit the local park, taking photographs of the trees and existing play equipment before deciding on a good place to build the treehouse. They might carry out some simple research, collecting images of existing tree houses and identifying and labelling what they find attractive about each tree house they research. They could carry out some simple market research of what activities children in the class might want to do in a tree house and present their findings as a pictogram. All these visual images that the children have produced are then collected together and presented as a class mood board about the project, which children can then refer to when working individually to create their treehouse designs. Brainstorming is also another technique used in Key Stage 2, where activities in Key Stage 1 can lay the foundations for brainstorming activities in later years. As part of the process for designing a puppet based on a favourite storybook character, children take part in a guided discussion about puppets, saying what they like about the puppets and what they think makes a good puppet. They are encouraged to listen to the views and ideas of other children in the discussion group and use the outcomes from the discussions to develop their own ideas for a puppet design. Computer-aided design is the use of computer software to create product designs. It is really just another drawing technique that is used extensively by designers in the 21st century. Using computer-aided design in design technology in primary schools provides an opportunity to make the subject real life and relevant. The important knowledge is that children develop an understanding of how computer-aided design allows the designer to change and modify a design without having to completely redraw and restart the design. Children should also understand how computer-aided design allows a designer to easily share their design ideas, for example electronically via email or social media, or by projecting their designs onto a large screen. In Key Stage 1, computer-aided design can be as simple as using Paint software to try out different ideas and be able to modify and improve these ideas without having to start all over again. Or if children have used tablets to create their designs, projecting these designs onto a large screen in the classroom, enabling it to be easily shared with the whole class. The second phase of the creative process is when children realise their design ideas by making their product, applying their practical knowledge. As well as actually making a finished product as the end point to the project, children could make a model or a mock-up or a prototype of their design as the end point. Like the process of designing, we can break down the process into 6 different areas. Learning a range of practical skills and techniques, knowing and using a range of tools and equipment, applying technical knowledge when making the product, working safely, keeping healthy and working within agreed guidelines, getting organised and getting ready to make the product, and creating a product with a quality finish. Just like for the skills and techniques of designing, the practical knowledge of making things is built upon as children progress through the curriculum. When making a product, children are taught and practice skills and techniques that allow them to make the product that they have designed. Some of these skills and techniques will be specific to a strand of learning, such as learning the simple running stitch to join textiles together, or learning how to grate fruit and vegetables using a box grater when preparing food. Some skills and techniques will cross over a number of learning strands and include skills such as cutting paper and cards using scissors. We will look in greater depth at these specific skills when looking at the technical and practical knowledge for each strand of learning later in this presentation. As children progress through the curriculum, they should experience knowing about and using a wider range of tools across each of the strands of learning in design technology. In Key Stage 1, children will be introduced to some of the basic tools used in cooking, working with different materials and textiles, making structures and creating mechanical systems that make a product work. They should know the names of these tools, what they are used for, and have experience of using them. So for example, in cooking lessons in Key Stage 1, children should learn the names of some common kitchen utensils and appliances and understand their functions when working with food and how to use them. In all their practical learning experiences, they should be taught how to use a range of tools correctly to perform practical tasks to join, combine, cut and shape a range of different materials. Many of these tools will be used again and again as children progress through the curriculum. So for example, using a needle threader to thread a needle is an essential skill when working with textiles, and the earlier that children are able to use this tool and the associated techniques, the better. When teaching how to use a range of tools and equipment, It is important that teachers model the techniques correctly and that this is consistent across the whole school. As children get older, they should develop an understanding of selecting the right tool for the task and being able to use that tool with less guidance and more independence. Technical knowledge is the knowledge of how something is made, how it works, and how it functions as it should. Children should be taught the specific technical knowledge related to the project that they are undertaking and the product they are designing and making. Once they understand this technical knowledge, they apply it when designing and making their product. The technical knowledge from Key Stage 1 National Curriculum is as follows. When cooking, pupils should be taught to use the basic principles of a healthy and varied diet to prepare dishes and to understand where food comes from. When building structures, children should explore how they can be made stronger, stiffer and more stable. And when designing and making products, children should explore and use a range of mechanisms such as levers and sliders, wheels and axles. These are just a broad outline of the technical knowledge from the National Curriculum at Key Stage 1, and teachers need to identify the key knowledge, skills and techniques that will be needed to allow the children to apply this technical knowledge when designing and making their product. So for the example on the screen, children are taught some simple mechanisms that can be used to create a pop-up card. Once they understand how the mechanisms work and how they are made, they apply this knowledge to make a pop-up celebration card by adding pictures, decorations and words to the mechanism. In order to keep themselves safe when working across a range of making activities, children should be taught the specific skills and techniques when working with a range of different materials. They should learn how to use the correct tools in the appropriate and safe way when applying a range of skills and techniques, such as holding a hacksaw correctly when using it to cut strips of wood, or how a thimble can protect their fingers when sewing. Children should know the specific rules and routines, such as working hygienically when cooking. Schools can support this through having a set of risk assessments that are known and practiced by all relevant members of staff and are regularly reviewed in order to keep children safe by minimising the risk of harm. Having a consistent approach across the school to teaching the correct skills and techniques to keep the children safe when undertaking practical work in design technology, by having standard sets of equipment that are used correctly and consistently across the school, with all relevant staff members knowing how to use them correctly and being able to demonstrate the correct techniques to the children. Ensuring that through the curriculum, children get better at the skills and techniques as they progress through the school. Teachers can support this by knowing the relevant risk assessments for the activity being undertaken and adapting them and applying them to the group of children about to undertake the activity. Knowing the correct skills and techniques when working with a range of materials, and teachers being able to model and clearly demonstrate these techniques to the children. Ensuring that the children have access to the correct equipment for the making task and knowing how to use them, and teachers reminding the children of the rules and routines that will keep them safe during the making activities. Getting organised is an important part of the creative process of making a product and is also an invaluable life skill. Planning to make is about getting organised and being prepared for the making session where they create the product they have designed. This can mean gathering together all the materials and ingredients they are going to need to make the product, knowing which tools and equipment they will need and the techniques they will use, and having their designs and drawings that will guide them during the making session. In planning to make, children should have a clear idea of the steps that they are going to undertake in order to make their product. In Key Stage 1, this might be quite teacher-led, providing the children with a model of how to organise themselves that they can use later in Key Stage 2. For example, children could have the opportunity to follow a recipe to create a food product, or have a to-do list to follow when working with food. Or when working as a group to make a product, children being taught to work collaboratively and to assign different tasks or jobs to different group members. We advise teachers that when planning out a sequence of learning for a unit of work, for the main making session when the children will create their product, Allocate a specific time for this activity and stick to it. There is no finishing off time. If the product is not completed, then the children can reflect on why they did not finish their product as part of their evaluation process. Whilst children are making their product, they should be encouraged to make it the best that they can. This helps to reinforce the iterative nature of continuous improvement in design technology. Towards the end of the project, as the product nears completion, it provides an opportunity for children to learn a range of different techniques that can be applied to make a quality finished product. Initially taught as a focused task or a guided activity, these techniques are then applied by the children to their own product as they are making it. It can be as simple as deciding on a base colour for the product, painting it, leaving it to dry before adding the final detail, or it can be about teaching a specific decorating skill such as adding glitter to a product. Section 4 and 5 of the audit covers the disciplinary knowledge of designing and making. Evaluation is the third discipline of the subject. Since they were very young, children have been making choices about what food they eat and like and what kinds of toys they engage with. As children start school, these choices are further developed, and children are provided with the knowledge to make informed choices about different products and are given the skills to articulate their reasons for the choices that they make. This is essentially evaluation, and this is made more formal as part of the creative process of design technology. In Key Stage 1, children are introduced to simple evaluation activities that get more complex and sophisticated as they progress through the curriculum. Children should be given the opportunity to evaluate products they have created themselves and also products and designs made by others, including their classmates. They can begin by answering simple questions about what they like about the product they have made and to identify ways in which to improve their product. They can also consider the process of making the product, what they enjoyed about the process and which parts they found difficult. Like in other areas of the subject, evaluation skills and techniques need to be taught. Often this can be done by allowing children to investigate and evaluate existing products, as in the example on the right hand side. When designing and making puppets in Key Stage 1, children investigate existing puppets, finding out how they are made and from what materials they are made from. They can also further this discussion by considering what they like about the puppets and as a class come up with some specifications for what makes a good puppet. At the end of the project, having designed and made their own puppet, they return to these specifications and evaluate their puppet against them. As children progress through the curriculum, taking part in evaluation activities, they should be reminded of the iterative process of ongoing evaluation when designing and making, instilling the mindset of how can I make this better. Here are some further examples of evaluation activities taken from the scheme of work. Having created a model of a treehouse, children answer some simple questions as part of the evaluation process. They then use the same questions to evaluate model tree houses made by their classmates. Having created celebration cards with a movable part, children evaluate their card product against criteria that were discussed at the beginning of the project when they investigated existing celebration cards with movable parts. When evaluating the Teddy Explorer vehicle that they have created, as well as saying what they like about their buggy and how they might improve it, children also reflect on the process of making the buggy and parts of this process that they found difficult. Having designed and made a storybook puppet, children compare their design drawings with the finished product as a stimulus to reflect on changes and improvements that were made during the making process. In this example, the design brief and design specifications are used to support the evaluation process by using them to generate questions that the children answer as part of their evaluation. So, when designing and making a Teddy racing buggy, have they made a toy buggy to enter the race? And have they met the design specifications? Does the toy figure fit in the buggy? Does the buggy have 2 wheels and an axle mechanism? Does the buggy look like the toy figure? Taste testing is the way in which children can evaluate food. Each unit of work involving food should include taste testing activities. Often a unit of work will have a taste test towards the beginning of the sequence of learning to teach and consolidate children's understanding of taste tests. Then, after the children have designed and made their food product, they will conduct a similar taste test to evaluate the food product that they have made. Children will use their senses of sight, smell, taste and touch to evaluate food and use their developing taste vocabulary to describe what their senses tell them about the food. As children progress through the curriculum, they will be extending and developing their taste test vocabulary. Particularly in Key Stage 1, children need to be taught the taste test vocabulary and link it to their sensory experiences. So, when taste testing apples, they can be taught what crunchy, juicy, sweet and tart means. In carrying out taste tests, there should be a consistent approach to how they are taught and the methods used across the school. Children should know the health and hygiene considerations when taking part in a taste test, and the complexity and challenge of taste tests should increase as children progress through the curriculum. In Key Stage 1, as well as describing the food using their vocabulary, children can state whether they like or dislike the food through words or a smiley face, and can be introduced to the idea of using a recording sheet to note down their evaluation ideas. As part of the disciplinary processes of design technology, children need to develop a technical vocabulary that allows them to access and fully understand the lesson content, communicate, articulate and discuss their learning, and understand more about the subject and conduct their own independent research. Many of the technical words in design technology are words that do not appear in any other curriculum area, and therefore they need to be taught, and their meaning and application in the subject needs to be understood by the children. This Tier 3 vocabulary may include words specifically linked to technical knowledge and the skills and techniques that children will learn as they progress through the curriculum. They may also be words that are linked to the disciplinary nature of designing, making and evaluating. As with many aspects of design technology, teacher subject knowledge may hinder effective teaching of vocabulary in the subject. It is recommended that schools develop a vocabulary of words and their meanings that are used consistently across the key stages in design technology. Once this has been established, then planning documents for a unit of work can include the vocabulary that will be used and taught within these units of work. Many schools, as part of their progression document, have gone further by highlighting when new words from the vocabulary list will be first introduced to the children. This is good practice, as it will inform the pedagogy of teaching this vocabulary. If the word is new, then the teacher should spell the word, explain its meaning, and then model the words in a sentence and highlight its use throughout the unit of work. If it is a word that the children already know, then they should be given the opportunity to explain its meaning and then use the word correctly within a sentence to illustrate their understanding of the word and its meaning in context. A vocabulary list can be downloaded from the Primary DT website as the basis for schools' development of their own technical vocabulary list. Every lesson from each unit of work in the Primary DT scheme of work begins with a vocabulary development session focusing on 3 words from the vocabulary list that are related to the learning content for the lesson. Here are some further examples of how technical vocabulary can be developed in Key Stage 1. Children's knowledge of the names of different fruit and vegetables can be developed. Children's knowledge of different tools they might use when working with a range of different materials, and linking words that describe the taste, texture and appearance of food supports children when evaluating food products. Section 6 of the Audit of Provision focuses on the disciplinary knowledge of evaluation and the range of different activities in the curriculum to develop children's skills in evaluating products and also developing their understanding of evaluation as part of the iterative nature of the subject. Section 8 specifically focuses on how vocabulary is developed as children progress through the curriculum, through planning for opportunities to teach the technical words of design technology. In this section of the presentation, we are going to look at the technical knowledge and associated practical knowledge and skills for each strand of learning in Key Stage 1. The technical knowledge in Key Stage 1 is defined as children should be taught to use the basic principles of a healthy and varied diet to prepare dishes, understand where food comes from, build structures exploring how they can be made stronger, stiffer and more stable, and explore and use mechanisms in their products. These are quite broad statements which need to be broken down into the key knowledge that the children need to know and remember in each strand of learning. We will begin by looking at cooking and nutrition, which is a key component of the design technology curriculum. Many schools in England devote a third of curriculum time to this strand of learning. This equates to 1 unit of study per year group. Teaching cooking and nutrition each year means that it is the easiest strand of learning to demonstrate progression, but conversely can also highlight a lack of progression in the curriculum. It is therefore important to carefully sequence learning so that children are building their knowledge in each lesson and unit of work. Such is the importance of cooking and learning in the DT National Curriculum that a separate section is devoted to the area, which is displayed on the screen now. The key areas to focus on in primary schools are teaching children how to cook using a range of techniques, the principles of healthy eating, to know how to prepare and cook a range of mainly savoury dishes, to understand and know where food comes from, and to understand seasonality and how this affects food production. In Key Stage 1, we can break down the national curriculum for cooking and nutrition into 5 main areas. Healthy eating, keeping safe and healthy when working with food, knowing and applying a range of cooking skills, knowing how to follow and write simple recipes, and food origins, knowing where food comes from. Healthy eating is at the heart of the cooking and nutrition curriculum. In Key Stage 1, children should be taught to use the basic principles of a healthy and varied diet to prepare dishes. Schools should have a clear message about healthy eating that informs both the curriculum and all other aspects to do with food in the school, such as school dinners, packed lunches, playtime snacks and treats for birthdays. This healthy eating message should be adhered to and modelled by all members of the school community. As far as curriculum provision concerns, cooking and nutrition activities in Key Stage 1 should be used to convey and consolidate the healthy eating message. Schools may have their own version of healthy eating, but the key principles should be based around eating at least 5 portions of fruit and vegetables a day, cutting down on sugar and salt, drinking 8 cups of water a day, and making the right choices in order to have a healthy and balanced diet. So at Key Stage 1, children should mainly be working with fruit and vegetables to create healthy dishes. They could create fruit kebabs, fruit salads, fruit smoothies, savoury salads, or savoury dips and dippers. Children can learn about the different dishes and how to make them, and apply their knowledge of healthy eating and use a range of cooking techniques to prepare them. In the example on the right hand side, the project challenges the children to design and make a fruit salad. Once the children have achieved this, the project reminds them about making the right choice by replacing sweets and sugary puddings and snacks with fruit-based food such as a fruit salad, reinforcing the healthy eating message. A separate presentation can be downloaded from the Primary DT website that covers healthy eating at Key Stage 1. The knowledge contained in this presentation could form the basis of teaching and learning in Key Stage 1 and underpin all learning activities in cooking and nutrition. In Key Stage 1, children should be introduced to the routines and practices that will keep them safe and healthy when working with food. In addition to maintaining good personal hygiene when cooking, children should be wearing appropriate clothing, including an apron. They can be made aware of any children in the class who have allergies or food intolerances and told not to share ingredients or equipment that has come into contact with ingredients that could cause harm to other children. Children should be clear about the routines to be followed when taste testing food. Also in Key Stage 1, there are opportunities to introduce knowledge around food labelling and the information contained on food packaging that can help them to keep safe and healthy. Schools should adopt a clear and consistent message for children to keep safe and healthy when working with food. These are the routines that are introduced in Key Stage 1 and built upon and consolidated throughout Key Stages 1 and 2. As well as understanding the importance of good food safety and hygiene and getting ready and prepared to work with food, children are taught a range of cooking skills that are revisited as children progress through the curriculum. The skills and techniques taught in Key Stage 1 do depend on the curriculum content, but the key skills are cutting and holding food using the bridge hold, cutting and holding food using the claw grip, weighing and measuring food, grating food, and juicing food. Other skills might include crushing using a mortar and pestle or garlic crusher, peeling, spreading, rolling, mixing, and sifting. It is important that these skills and techniques are taught consistently across the school using standard sets of equipment and utensils, as this will reduce the risk of children harming themselves. An example of a cooking skills progression chart can be downloaded from the resources section of the Primary DT website. This example on the right hand side is taken from a Year 2 project focusing on rainbow salads. To consolidate healthy eating messages, children are challenged to design and make a rainbow salad containing fruit and vegetables that are of different colours and have been prepared in different ways, allowing children to practice the cooking skills of cutting using the bridge hold and claw grip, grating food using a box grater, and juicing a lemon to use as the salad dressing. Being able to follow a recipe to create a food product is an important element in cooking and nutrition. A recipe is a set of instructions that provides step-by-step guidance to create a food product. A recipe is a way of communicating the end point of activities when children are designing food. In Key Stage 1, children should learn how to follow a recipe to make a food product, know some basic recipes, and begin to understand how to write a recipe. As part of their learning, children can also begin to use the information in recipes to get ready to cook by identifying the ingredients and utensils that are needed and the tasks that are needed to be performed in order to make the food product. As part of the cooking and nutrition curriculum, children need to know and understand where food comes from. In Key Stage 1, children need to know that food comes from plants and animals, much of which is produced on a farm. They need to know the names of some common food commodities and how and where they are produced, and they should also be developing an understanding that different foods come from all over the world. Activities linked to where food comes from are a good introduction to a unit of work and can act as the hook for future learning. These activities can include discussing about food to find out what the children already know, a visit to a local supermarket or town market to see what's on offer, or direct teaching to extend children's knowledge of different foods, In Key Stage 1, focusing on fruit and vegetables, where do they come from, and knowing the difference between a fruit and a vegetable. But the main focus of teaching in Key Stage 1 is that all our food is either grown, reared or caught, and children knowing which foods are grown, caught or reared. Children should know the origins of common foods and particularly foods that they are working with. It can be as simple as knowing that apples grow on trees in the UK, or that cream is a product made from milk that comes from cows that are reared on a farm. As well as the resources that can be downloaded from the Primary DT website, the Food A Fact of Life is your one-stop shop main resource for teaching and cooking nutrition in primary schools. In Key Stage 1, children should have the opportunity to work and make with a range of materials, including food ingredients, textiles, sheet materials, for example paper, card and cardboard, and wood, strips of wood for making framework structures. And in doing so should understand the different properties of these materials and how these may affect choices made for which materials to use when making products. When working with a range of different materials, children should experience and develop skills and techniques to use these materials when making a product, including measuring them and marking them out, cutting and shaping them, joining them together, whether permanently or temporarily, and finishing and decorative techniques. In the examples on the screen, you can see how children's skills and techniques with working with wood can be developed by gaining their woodwork license, and how specific techniques can be taught to children to enable them to create structures using cardboards. Children will gain knowledge about working with a range of materials and their properties and the associated tools and techniques in each unit of work that they undertake. Although not specifically referenced in the national curriculum, working with fabrics and textiles is an effective way of developing children's knowledge of working with sheet materials. In Key Stage 1, children can learn the skills and techniques of cutting textiles and joining fabric pieces together by sewing, gluing and stapling. They can be taught the running stitch to join two pieces of fabric together to create a permanent join. Teaching this technique also provides an opportunity for children to learn how to use a thimble and a needle threader when sewing. Children are able to practice their sewing techniques using binker material, which they can decorate using patterns using a range of embroidery stitches. Creating a product such as a puppet also allows children to begin to learn some different techniques that can be used to decorate fabrics and textiles, such as using felt tip marker pens, fabric paints and pens, applique, and adding embellishments such as buttons, wool or sequins. In Key Stage 1, children should have the opportunity to create structures by joining different materials together and exploring how these structures can be made stronger, stiffer and more stable. Children will be building upon their experiences from early years, where they may have made structures using junk modelling and construction kits such as Lego or stickle bricks. In designing and making structures, children can work with materials such as paper, card and cardboard, and begin to develop an understanding of their properties and how they can be joined together to create structures. Children will develop and extend the range of tools and techniques that they use when creating these structures. In the example on the right hand side, children design and make a model of a monkey enclosure for the local zoo. Having investigated existing enclosures and considered the different types of monkey activities such as climbing, swinging and providing somewhere for them to sleep, children design their enclosure. Having taken part in a focused activity to create a model swing and learnt some techniques for strengthening this model and making it more stable, they apply this knowledge when making a model enclosure using art straws, card, string and cardboard. In another example of creating structures, children used the Jinx method for creating wooden frameworks to make the chassis for a Teddy Explorer vehicle. The wooden frame provides a strong, stiff and stable structure to add the wheel and axle mechanisms that turns rotational movement into linear movement. Using the Jinx method for creating wooden frames can be further developed in Key Stage 2, where children can create photograph frames, prototype animal homes, or to make a strong framework to house a mechanical system such as a cam, gear mechanism or pulley mechanism. When learning about mechanical systems in Key Stage 1, children begin their learning journey of understanding systems that will be developed further in Key Stage 2. Children are introduced to the idea that all systems have an input and an output, and that systems make a product work. In learning about mechanical systems, children will know and understand that a mechanical system produces movement, and that linear movement is movement in a straight line, and rotational movement is circular movement. There are several different types of mechanical systems suitable for Key Stage 1. Children could learn about how sliders produce linear movement, and a simple lever and pivot can create rotational movement, and apply this knowledge when making a celebration card with a movable part as seen on the screen now. Both examples come from the Key Stage 1 unit of work on celebration cards. Or, having learnt how a wheel and axle system turns rotational movement of the wheels into linear movement of the vehicle, children design and make a teddy vehicle to take part in the class teddy race. Section 9 of the curriculum audit covers technical knowledge linked to the strands of learning in design technology. Some children will demonstrate a high level of understanding and ability in design technology, whilst others may struggle in the subject or aspects of the subject. All should be supported to ensure that they all achieve the designated learning outcomes for each project. In this short section, we provide some generic challenge and support strategies that can be used to support teaching and learning across the design technology curriculum. Also, as part of the planning process, teachers should consider specific resources and strategies that can challenge and support children specific to the unit of work they are planning to deliver. Challenge strategies are for those children who demonstrate an increased understanding or ability in the subject. These children should be provided with opportunities to deepen their understanding of the curriculum content. Challenge does not mean introducing new curriculum content or knowledge. Challenge strategies can include encouraging children to go deeper into the iterative process, to challenge them through each of the phases of the iterative process to improve on their designs or to add more detail or a higher quality finish to their product. It can also be about higher expectations and detail and sophistication in their designs. Challenge can also be about encouraging these children to show leadership and delegation when working in group-based activities and situations, or to act as a buddy or a mentor to a child who may struggle in the subject. Here are some strategies that can be used to support children to ensure that they can achieve the learning outcomes in design technology. Some children may not have secure knowledge in some key skills and techniques, and so during the investigative and focus sessions, teachers can identify the children who need additional support in the design and make and evaluation activities. To enable children who may struggle to gain the necessary knowledge, skills and techniques, consider one-to-one or small group work with adult support when undertaken focused tasks and practical activities. If learning in the session requires children to retrieve previous learnt knowledge, then check that they have, and if not, pre-teach this knowledge. Ensure that children fully understand any technical vocabulary for the learning session through pre-teaching and prompt cards. To enable children to fully engage in discussion and brainstorming activities, provide them with ready-made questions. Some children may struggle to communicate their ideas when designing a product. Use adult support or another child to act as a scribe to write down or draw their design ideas. Design activities can also be scaffolded to help children to realise their design ideas. This can be achieved by providing children with drawings for them to label and annotate, or providing them with keywords and annotations to add to their drawings. When working in group activities, make informed choices about these groupings, or consider buddying up children who may be struggling with a more able pupil. Some children may not be able to accurately carry out necessary skills and/or techniques to enable them to successfully complete the design and make project, but this should not exclude them from making and completing their product. Provide them with the necessary materials, tools and techniques to support them. So for example, if a child struggles with accurately measuring and cutting strips of wood, then provide the children with pre-cut wood for the design and make activity. Or provide children in cooking activities with prepared and measured ingredients to enable them to follow the recipe to create their food product. When evaluating products, children could work as part of a guided group or have guidance to follow or to answer a set of questions to enable them to evaluate effectively. One of the phrases that has been often used in this presentation has been "as children progress through the curriculum," because the essence of learning in a subject is that you get better at the subject the more you study the curriculum, navigating the knowledge to reach the curriculum endpoints. This is progression. In considering progression and assessment in design technology, we need to consider one of the underlying principles of the subject, that children build knowledge. To ensure the curriculum promotes knowledge building, we need to develop a curriculum that sets out explicitly what the children are expected to know and remember at each stage of their learning journey. And this can be done at various stages, at each lesson, in each unit of work, in a year group and over a key stage. And this is the knowledge from the four domains of subject knowledge, disciplinary knowledge, practical knowledge and technical knowledge. We also need to develop a curriculum in which teaching and learning is based on securing this key knowledge and making sure that the children know and remember it. We need to develop a curriculum where knowledge is carefully sequenced with plenty of opportunities throughout the learning journey to revisit and recall this knowledge, linking it together and adding new knowledge to create a better understanding of the subject. Mapping out the knowledge that children are expected to know and remember is the purpose of a progression document. Not only does it sequence children's learning, it can also be used by teachers to identify what the children should know already from previous learning, and also the knowledge that they are expected to teach to the children that will be built upon in later years. An effective progression document maps out the learning journey from early years right through to the end of Key Stage 2. It is a roadmap that details the learning journey and knowledge acquisition that the children need to reach the early learning goals at the end of the foundation stage and at the end of Key Stage 1 and Key Stage 2 expectations. Taking time to develop a detailed progression map which clearly states what the children should know and remember supports effective assessment in design technology. Teachers identify whether the children are on track and are expected to reach the end of key stage expectations. In other words, do they know and can they remember the knowledge that they are supposed to at the end of their learning journey, or are they working towards the expectation and need further support to reach these expectations? In our scheme of work, we include 5 indicators for each unit of work to show that children are keeping up with the curriculum. This can help teachers to make a judgment about whether individual children are where they are expected to be and that the teacher is confident that the child is on track to reach the end of key stage expectations. This screen also shows how in the medium-term planning in the scheme of work, children can be challenged by deeper learning and supported to achieve the learning outcomes. Progression through the curriculum is often demonstrated through a progression document. There are many different formats for progression documents, but all should focus on identifying the key knowledge that children are expected to know at each stage of their learning journey. In our scheme of work, we have divided the knowledge into what children should know and what children should know how to do. These simple statements allow teachers to make a clear judgment. Do they know it, yes or no? And if they don't know it, then reteach this knowledge. In the example on screen taken from our scheme of work, the knowledge that the children should know about the disciplinary process of designing is indicated for Key Stage 1, Lower Key Stage 2 and Upper Key Stage 2. As well as making progress in the disciplinary knowledges of designing, making and evaluating, children also need to make progress in the technical knowledge for each strand of learning in design technology. And again, we use the same format in our progression document. Schools in the Flying High Partnership that are separate infant and junior schools might like to consider collaborating together on their overall DT curriculum or progression document to ensure that children continue to build knowledge and continue to make progress in the subject when they transfer schools from Key Stage 1 into Key Stage 2. Our progression document, called the Curriculum Pathway, can be downloaded from the Resources section on the Primary DT website. Section 10 of the Curriculum Audit focuses on curriculum progression and assessment, and Section 11 of the audit looks at the overall curriculum structure and the rationale for it. Just a reminder that there is a dedicated page on the Primary DT website for schools in the Flying High Partnership. We hope you have found this presentation useful and informative.